Hi there. Welcome to another exploration of a STEM activity lesson that we've created on ClassPad.net. The link to it is below in the description. I'm using ClassPad.net, free math tool. I highly recommend you create an account. It's free. And if you like the activity that I'm sharing today, you can save it if you have an account. So that's a reason to get an account. But you can also create new things and start using this with your students all the time. So here's the landing page for ClassPad.net. Pretty easy to just create an account by clicking this button. If you don't want to do that quite yet and want to see what it's about, start exploring, and you can pretty much do, as you note down here, any math you want. So I'm going to go right into the activity. It's a URL. So when you open the URL, you get the activity here. Sorry, I had a button pushed. And this is an activity that students could actually do. It's relatively easy. You don't need a lot of materials. You need 4 different types of balls that bounce. So football wouldn't work, but tennis ball, golf ball, ping pong ball, basketball, anything that bounces. And you're basically going to create, and so you'll notice that this activity kind of is talking about what we're looking at. We're looking at the energy. So we're measuring how high the ball rebounds after its first bounce. That's the first part of the activity. It shows you the materials you need. So it's not a lot. You need a way to mark a wall with measurements. So you could just tape a tape measurement up there and do it that way, or you could, as they suggest, get paper, cover it, and then mark the wall. And you want to kind of go as high as, if you're with students, they may not be that tall, but 6 feet maybe is what you want to do. And basically what you're going to do is you're going to hold the balls, each one done separately, at a different height. So maybe you start at the highest height and you drop it and you measure where the bottom of the ball rebounds to. So you kind of need 2 people paying attention to that. And you're going to do that for each ball, and you're going to do different heights for each ball. So you're going to drop them from different heights and just record the rebound. So that's explaining the activity. And so what I want to note here is that in this ClassPad activity, you actually are going to see some neat features of ClassPad. You can insert images. So this is an image of a tennis ball, and this is using sliders. So sliders move the ball. I'm going to show you how to do that, but you can create a slider, and this is a time, and so this slider is sort of helping them understand what they're going to be doing. They're going to have this ball at a certain height, and they're going to drop it, and they're going to measure. So this is what this is discovering. I'm just going to show you what you can do with the slider. If I click the slider, you can see the ball being dropped, and they're going to let it bounce, and then they're going to measure how high it is. And that's about where it stops right there. So we're going to, at time 1, the height, the first rebound is at 1. So it started at 1.5. Obviously, we didn't rebound as high, and they're going to record that. So this is sort of more of an explanation of what they're going to be doing. So then they collect their data if they're doing it themselves. But I do want to point out that if they don't have their own data, there is sample data provided. So you can still do the experiment. You can understand what's going on, but use the sample data instead. So I'm going to use that real quick to show you what they're going to do. They're going to, in the first part, they're going to make a scatter plot for each one of these. So you have height and then all the different balls. So here's the different heights each ball was dropped from, and how high the ball rebounded after that first bounce for each height. And so we're going to basically make 4 scatter plots because we have 4 balls. So I'm going to select the first column and the second column, and I'm going to go to my graph and scatter plot. And so here is my first scatter plot. I'm going to kind of pull it up here. And that's the nice thing about ClassPad. As you can see, I can move things around so I can see them. So what do I notice about the first ball? Well, the relationship as the height is increasing, what am I saying? As the height is increasing, the bounce increases, right? So the higher I drop the ball, the higher the bounce is. So let's see if that's true for all of them. So then we're going to go back and do the same thing for each, and you'll notice that each scatter plot gets a different number, and it does also appear to be linear. And if I continue to do that, select the height and then ball 3, I'm going to end up with 4 different scatter plots, different colors. So that's a nice feature. And let's do that last one real quick. So there are my 4 scatter plots, right? So maybe I want to move this off to the side here. And I can see which color goes with which. And so they're going to talk about what do they see, what does that actually mean, and then they're going to be asked to do a regression. Regressions are just as easy. You can do the same thing. You select the column, the ball, and then you go back and go into regression. And since this looks linear, we're going to use linear regression. And I'm not going to do all of them. So this one is the first one, right? And you can see that's my, if I look at the regression, they're then asked, can you explain what that slope actually represents in the context of this? So they're really talking about what's the relationship, how is the energy changing over as you decrease the height or increase the height of the ball being dropped. What happens to the bounce? That's what they're going for. So they're going to do the regression for each one of them. I'm not going to do that in this example, but that's what they would then do. So they do this, they explore, but then there's an extension, which is where this simulation is going to come into play. They're asked, this time we're not going to look at just the first rebound. We're going to record the rebound for all of these. And so we're going to use that simulation again and actually record the height on this. Now, they could do this with their own balls, again, starting at the top and then just record the different bounces. But if they don't have it, they can use the simulation. So that's a nice thing. So let's just play it. And we're watching the ball. So that's after its first bounce. I probably should start at the beginning. And here's its second one. And we want to figure out where it's going to stop. Well, it didn't go as high. So it's about at, let's see, we're going to call that point at time 2, or at bounce 2, it's like at point 7, I'm going to say. And so they're just going to record each one of these, right? And if we continue, let's see what we get at the next bounce. So it's going down, and now we're going to the third bounce. And that looks like that's at point 5. And then if we keep going, so I have 2 more. So now here's our third bounce, definitely not as high. And that looks like that was at point 3. And let's do our last bounce. And again, they may have something more precise. It depends where they want to stop it. And that one looks like it was at, I'm going to say 1.5 or 0.15 is what I meant to say. So then once they do that, they've collected their data. And again, either using their real balls or the simulation, then we're going to also do a scatter plot. And this one will look different. And if we look at it down here, it doesn't look quite linear. It's supposed to be exponential. And so when we go and do the regression, we're going to use an exponential model. Oops. And they're going to talk about why is that different. And it's, you know, what's the relationship between each successive bounce and the height, those types of things. So this is the exploration, and it's all about energy conservation and what happens over time. So have fun with that. I like this because it has lots of different options, sample data, simulations, those types of things.